break. Here we go. It's Geometry Shapes Class 2.0 Electric Boogaloo. Too Fast, Too Furious. Ants Van Reloaded. Okay, so the warm up for today is going to be this. So this is sort of where this came from, sort of not. Okay, so imagine you are a video game maker or something like that, okay? And you have two buttons, the A button and the B button, and you want to make a fighting game. And so you're trying to figure out all the different combinations of buttons that you can do. Now, your video game that you've made can accept a total of 4 inputs. 4 inputs before it recycles. So meaning that you could press A 4 times, and then after that, the 5th time, it would restart the combo. So if you press A once, you do a punch. If you press A twice, you do punch, punch. And if you press A 3 times, punch, punch, punch. And then 4 times, punch, 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 right? Okay, something like that. And then there's B that you can mix in. So you have a 4 combo thing, right? So what I want you to do is take these letters, 2 A's and 2 B's, and I want you, there we go, I want you to find all the different ways to write those down. So obviously you could just do single A, right? You could also just do single B, so that's 2 combinations right there. What other combinations could you do? Now, your video game works in such a way that A, B is the same thing as B, A. So that's the same combo. It works the same way. Just trust me on that. Find all the different ways to write that down and prove that there are no other ways if you can. Like, find a way to show that. That's your warm-up. Hello.
Let's go.
Get it from someone who cares.
But they don't have it because when you enter it,
So
it's gone.
does that mean like ABB is the same as BAB?
ABB is the same thing as BBA.
So does that mean we can't use 3 A's?
Nope, only 2. You have a max of 2. 2 A's and 2 B's. We're keeping it simple for now. That's it. Song today is Triangle by Bad Bad Not Good. Bad Bad Not Good is a jazz trio. They're rad.
He's probably not.
Do they have to all be used in every time?
What?
Do they have to all be used in every time?
No, you can use that.
I don't even know what's going on.
This Friday.
Yeah, well, he said he'll bring it in whenever he wants.
All you
Basically, he said the smart people bring it on Monday, and then the dumb people bring it in on
I don't know.
And
I
like,
like
if
them all.
the people that bring it in on Monday will probably be your bosses and.
Yes, that's what
I mean, either. I'm gonna be on streets. I'll turn it help. I'll turn it on Friday. We get our homework today. We became an orphan. Yeah, and we won.
triangle, but bad, bad, not good.
I would agree.
Well, what should I play?
I'm glad you agreed. All right.
You have to.
So, who's got some for me?
Me.
Go ahead, Haley.
Powerhouse House.
A.
A. Good job.
B.
And B.
And
And AA.
Stop now.
And
That's
BB.
all I had.
AB.
And AB.
ABB.
ABB.
And BAB.
BAB.
ABA.
ABA.
BAA.
BAA.
AABB.
AABB.
ABAB.
AABB. What?
ABAB.
ABAB.
ABBA.
ABBA.
And BAAB.
BAAB.
What I got?
Wow, anybody get any that aren't on here? No? You got 13. Yeah?
So if you were to do AB, could you also do BA? Or is it no?
It's a good question. I said no.
Okay.
I did AAB.
AAB. That one's not on there.
And BBA.
Isn't that the same as BAA?
BBA is already there.
Oh.
AAB. Oh, it is on there. Sorry. Oh. Oh. $13? Cool. You wanna know how I did it? I did it like this. If I move to the left, it means I'm adding an A. If I move to the right, it means I'm adding a B. Okay? So I'm gonna move to the left, and I'm gonna get AA. I'm gonna move to the right, I'm gonna get BB. If I move to the here and here, I get AB. Notice I added an A moving to the left, or from here I added a B moving to the right. So that covers all those. If I move to the right, I get AAB. If I move to the left, I also get I get ABB. ABB. Move to the right again. I get these. Now I only got 1, 2, 3, 4, 5, 6, 7, 8. We found that there were 13. So where did the other ones come from?
They're doubles.
How?
Like, they could be, like, reverse and do the same thing.
Well, we said reverse doesn't count. So like AAB didn't count because we already had BAA,
Right.
right? So which ones? Can you explain? So
Well,
like,
we got more because, like, you had AABB, and she might have also had BBAA.
say it again.
AABB and BBAA, they're the same thing. That's
Right.
why she-
BBAA did not count. We don't have a BBAA on here. Because that would be the same forward and backwards. Where do the other ones come from? Yeah.
Well, you can have BBBB.
Yeah.
BBBB.
Can you?
Nope.
Why not?
We only had 2 B's and 2 A's to work with.
So that's what that was for.
Yep.
I asked.
Welcome to class. Hannah, take care of Taylor, please. What?
It's not working.
You what?
It's not working.
Okay.
Can you flip back over?
Yes. Where do the other ones come from? How did she get 13 when I only got 8? And I'm not saying my answer's right. I'm saying her answer is right. I'm missing stuff.
Just turn it. Don't make eye contact.
The ABBA and the BAAB, weren't those be the same?
These two?
Yeah.
So we said forward and backwards would be the same thing. So if I had BAA, or if I had ABBA and ABBA, it'd be the same forward and backwards, right? So I wouldn't count those twice. But these are two different ones. This is true. So why don't I have that? Can't this also be written as ABA? I added one B, right? I just added it on the end instead of in the middle. Couldn't I also write this one as BAB? Right? So that's where those extra ones came from her. And then this one has a lot of different variations. We could do this one. We could do this one. Actually, no, we can't. This doesn't have a lot of variations, does it? No, it does. Yeah, this one too. Any others? Nope, that's all 13 she had. What's today's date?
The 13th.
The 13th, oh my god!
Conspiracy.
He's a wizard.
Wow.
He's a wizard. It's not
Can you go to
conspiracy,
the other
it's
side real
coincidence.
quick? I think I missed one. Thank you.
Why are we doing this? I'll show you why.
Congrats.
Oh, I missed one too.
I missed ABBA.
Oh my god. Did you see that?
You're sitting in a very dangerous spot, Dylan. Alright, so
Yeah, see how many-
100 points to Gryffindor if you can guess this shape.
Triangle.
Good job. 100 points to Gryffindor.
Thank you.
Minus 100 points to Gryffindor for talking out of turn.
Gosh.
Why do they call it a triangle?
6 minutes.
Yes, three angles.
Very good. It has 3 angles.
Are we supposed to be like writing this somewhere?
No, and it also has 3 sides. So, instead of A's and B's now, I have S's and A's. You can spell some funny words with this. Alright, so, how many different combinations of angles and sides can I have? Well, using my method of angles and sides, I'm going to move to the left, and that's going to add an A. And if I move to the right, it's going to add an S. When you have 2 options, this is a really good way to work it because we can move left or right, which is a binary. It's 2 different things. Do it, I dare you. Do it. Just hurry up.
No.
Coward. How many A's do I have here? Max.
3.
How many sides do I have max?
3.
Awesome. So if I move to the left once, I get 2 A's. Move to the left again, I get 3 A's. There's all my combination with just A's. Here's all my combinations with just S's. What happens if I move to the right? Adding an S. And if I move to the left here, it gets me in the same spot, right? Cool. What about moving to the right here? What do I get?
2 A's and 1 S.
2 A's and 1 S. Wow.
Were we supposed to dash this?
That wasn't the goal, but somehow it worked. Here you go. This is your final chance.
Uh-oh. Got the bad.
That inappropriate.
So much further off than the last one.
Words. It's like
Go for letters. I'm going for letters. Don't need some attention.
I think you should put
right?
Yes.
If I had an A, I get here.
Awesome.
What else am I missing?
A. What about A, S, S, S? That's 3 A's.
But there's 3 A's in the triangle.
Yep.
Oh, yeah, sorry, my bad.
You better be bad.
A, S, 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 A. Asa. Sounds like a bad Japanese restaurant.
And then at the top, the pinnacle, which is right here. I'm gonna write it like this.
I think it's like the top of a mountain.
Sure, I was gonna see if I could find a video of you
Yep.
singing, but I decided to.
Is that true? Hold on a minute.
That's all of them.
Yes, it is. Pinnacle. I'm gonna fact check it.
That's
why
all
he
of
said
them.
pinnacle.
So the reason I did this is because we're going to explore today what makes triangles the same. So we have angles and sides to deal with. Now, a triangle is congruent to another triangle if all of its parts are the same. So we call those corresponding parts, kind of like corresponding angles that we learned earlier, right, Cap? And so if the corresponding parts of each triangle are the same, then the entire triangle must be the same to the other triangle, therefore they are congruent. And that's how we're going to define congruency, okay? So we've got lots of angles and lots of sides. Now, instead of having to check every single side and every single angle between two triangles to see if they're the same, right? Are those angles the same? Yes, they are. How about this one? How about this one? How about all the sides, right? I want to know, is there a shortcut? Is there a minimum number of things that I can check to know if two triangles are exactly the same? So for instance, if I have a side, and I have the same side for both, right? Here's two triangles, they have the same side. How many triangles can I make with just this side? Well, let me rephrase that. How many triangles can I make that use this length for one of its sides? Well, I can make this triangle. Stop rolling. Are we on a hill in here?
My grandma used to.
Check it out. There's one triangle I can make using that length for a side. But then again, can I make another type of triangle using that same length on the bottom? Sure I can, right?
You could make a million.
I could make as many as I wanted, couldn't I?
Yes.
Right? So, just knowing one side is the same between two triangles isn't enough to prove that they're congruent, right? Because they could be different, right? So one side is enough. What about one angle? Angles are a little bit harder to deal with. So what I'm going to do is this.
Yeah, I use that.
I'm going to draw an angle using this.
Anal likes to make great. I'm bored.
So using that angle. Again, just the angle, not the size. Can I only make one triangle with this angle? Or can I make more triangles using that same angle?
Yes, you can make more.
I can make more. Now, it might seem like there's only one you can make, right? You're like, that one, the one that connects those two. But, I can take that same angle, but different lengths, and make a different triangle, and I'll show you.
So you could still make.
So look, same angle, but different triangle, right? So one angle is not enough. You can't just find one angle between two triangles and say, oh look, same triangle, right? Not enough to prove that they're congruent. So, one side, not good enough. One angle, not good enough. And the reason I ordered it this way is because pretend we found out that if you know two sides of a triangle match, right? If we knew that, then that would mean anything with two sides already known would also work. So if this worked, this would work too, because it already has two of the sides, right? If this works, then so would AS, right? Because it has two of the sides already known, right? It's extra information, but it would work, right? So what I'm trying to do is find the minimum number of ingredients, the minimum number of sides or angles that I need to prove two triangles congruent. And once I find that, everything else I get for free, right? So right now, single side and single angle doesn't work, unfortunately. If it did, everything else would work as well, right? So let's work with some others. So I know one angle isn't enough. What if I know two angles of a triangle are the same? So let's do something like this. And I know that since it's a triangle, these are the two angles. I know I have to use those two angles. Now it might look like this is enough, but it's actually not. It's kind of hard to show though. So using the same angle and this same angle, right? Again, it has nothing to do with the side lengths, but it has to do with the angle. So there's that angle. There's this angle. And I can show you right now, oops, I can show you they're not sticking all together. Flip, please, thank you. Right. So check it out. Same angle here, same angle there. But did I make a different triangle? Yeah, I did, right? You can imagine filling that in. So that's not enough to prove they're congruent either. So 2 angles isn't enough. Do you think 3 angles will be enough? If I know all 3 angles, will that be enough to prove it or no? Why not?
Because it can get longer.
Exactly, the length can change. So check it out. I know all 3 angles here, right? Those are the angles I'm going to use. Well, these 2 angles are already done. And I want to use this angle as well. I hate when this gets reversed. All the angles check out. They're the same, right? But are the triangles actually congruent? No, they're not. We call this similar, and we're going to learn about that later. They are very similar triangles, right? They're pretty much the same, but they're not actually congruent. So all 3 angles isn't enough. Here's what I want you to do. Get out a piece of paper and a protractor. Protractors are back there on the table by Autumn. Try to figure out the minimum number of things required to prove triangles congruent. Use this chart that I have up here to check. Are 2 sides between 2 triangles enough? Again, use the ruler and the angle measurements on the protractor to check your work. Work together so you don't have to try every single one of these on your own. Obviously, the top part right here, if we know all of this information, all the angles and all the sides, then we know they're congruent, right? That should be enough to prove it, right? All the parts are the same. That'll be enough to prove 2 triangles congruent. So that's kind of a given, right? But do we need to know everything to be able to prove that? So let me restate it. I'm glad you're confused. Ready to have some of your questions answered?
I don't really have questions. That's how confused I am.
Exactly. So I know that if I know all the angles and all the sides between 2 triangles, right, and that they're congruent, then I know the triangles are congruent. So if all the angles of this triangle and all the angles of that triangle are the same, and all the sides are the same, then I know that these are congruent. So for instance, if I had a triangle like this and a triangle like that, and I know these 2 angles are the same, these 2 angles are the same, and these 2 angles are the same, that's not enough to prove it's congruent. We found out earlier, right? Because they could be different sizes. But if I know that these sides are the same, and these sides are the same, and these sides are the same, and all those angles are the same, then of course they're congruent, right? Everything's the same, so they must be congruent to each other. But I want to know, do I need to know everything about these triangles to be able to prove they're congruent, or can I have a little bit less information to know that they are? Is there a shortcut? Do I need to check every single angle and every single side to make sure they're congruent? Turns out you don't. So I'm asking you, what's the minimum number of things you need to know to be able to prove they're congruent? You get the rest for free after you know a certain amount. So for instance, if you prove that 2 sides is enough, like if you check 2 of the sides and they match, if 2 sides is enough to get it done, to prove that they're congruent, then everything that has 2 S's in it will also be enough, right? Because 2 S's will be the minimum. So everything touching that has 2 S's in it, minimum, will be also be congruent. So what I want you to do is check each of these and see if that's enough information. If you know 1 angle and 1 side, is that enough to prove 2 triangles congruent? If not, make 2 triangles that have the same angle and side but are different, right? Maybe they have the other 2 sides bigger, right? I don't know. Check each of these. So if I were to check this one right here, sides the same, right? These triangles both have two sides that are the same. Is that enough to prove that these triangles will be congruent? Well, no, right? Let's check it out. Can't I have one triangle that looks like this? It's kind of gross, but. And then one triangle that looks like this? Maybe I should switch colors on here. So the yellow sides are the congruent sides, if you can't tell just by size. So check it out. Just knowing two sides are congruent between the two isn't enough to prove the triangles themselves are congruent, right? Because here's a case where both sides are congruent here and here, but they are different triangles. So it turns out this is not enough information to prove they're congruent, right? You need more. So how much more do you need? What's the minimum amount?
3.
Calvin says 3 sides. So if we know 3 sides are all the same, there's only one way to make that triangle, right? Anything else that I do with different angles, right, doesn't make it a triangle. So there's only one way I can make a triangle that has these 3 lengths, right? Only one way. Everything else wouldn't actually be a triangle. So 3 sides is enough. So if we know 3 sides of a triangle match, then they are congruent. Turns out their angles will also be the same. Even if I do something like this, right? If I had to use those, there's only one way I can make that triangle, right? Like this. Turns out they're exactly the same. So as long as the 3 sides are the same, these matching these matching these matching these, then the triangles will always be exactly the same. Is there other stuff that I can check? Experiment. Use your protractor. If you're trying to mess around, draw 2 angles that are the same, right? And then draw 2 sides that are the same and see if there's only one way to make those triangles. Work with it. I'll walk around and help you guys, okay?
How do I draw an angle on the protractor?
I'll show you guys. If you're confused about protractor stuff, because it's been a while since we've used them,
We've never this one says that.
So this is
we used them a little bit, just not very much.
I use them to draw straight lines.
Alright, so if you want to draw an angle, let's say I want to draw a 50-degree angle. Here's the 50. I'm going to draw a line. Okay, there's my line. I'm going to put my protractor on it.
Can you start over?
I'm drawing a line. Pretend I started over. I began. I drew a line.
Okay.
Alright, so I'm going to take my protractor and put the end of that line right here, where I want to draw my angle from. And I'm going to make sure my line lines up with this line on my protractor. Okay?
Can't even see that.
You're not even looking, so that would help.
Yes,
Just
I
make
would
sure
look
that
at
you're-
this.
Alright, so see this line?
Make sure the line is up there.
With the circle in it?
Yep, right here. I want to make sure that line lines up with my line.
Okay.
Now, see where it says 50? Going from 0 to 50? I'm going to put a dot there. And that's going to make my 50-degree angle. Now I have a dot, and when I connect the end of this to that, it'll be 50 degrees. There's 50. Now, why do they have 50 here and they have 130 as options?
Because that's like centimeter way.
Nope. It's not feet and inches, or centimeters and inches. It's not that. Why do we have 50 and 130 both
So
listed
then
in
we
here?
go around
Reflex.
again.
So check it out. If my line was going from here to here, that would be 130. How do we know that?
130 plus 50 equals 180.
What theorem says that this has to be 130? What theorem says 2 angles on a line are going to add up to 180?
Linear
Linear pair theorem, very good. So, depending on which direction you're coming from, if you're coming from this way, it's 50. If you're coming from this way, it's 130. That's why it's there. So, draw yourself some angles. Draw yourself some lines using the measurement, the inches here. And see if you can make triangles that are different using only this information. So, if I wanted to check angle side to see if that was enough, I would need to have 2 triangles with the same angle. and a single side that's the same. So I'm going to do this with my graph paper. I'm going to have a side length of 4. I'm going to make an angle of 50 degrees. So I know that this is 50, and this has a length of 4. If I do another triangle with a length of 4 and an angle of 50, is that enough to prove the triangles are the same? Now be careful. Just because I drew those two lines like that doesn't mean they have to be the same length, right? Only these two have to be the same length. We're checking side angle. So I have an angle that's the same and a side that's the same. What if I make this side longer? Which is totally allowed, right? Because I only have to have one side that's the same to start out with. I could make a triangle that looks like this, whereas this guy looks like that. Are they the same triangle? No. So side angle isn't enough to prove that these two are the same, right? I can make a triangle that's different. So if you follow the rules and it says side and angle have to be the same, which I did, and can draw two different triangles, then it's not enough to prove that they'll always be the same, right? A side and an angle being the same isn't enough to show that the triangles are the same, right? In this case, I just showed you, I have two sides that are the same, two angles that are the same, but they are different triangles. If I have three sides that are the same, like this, that's 4, and this is the same because it's over 2, up 3. I know that's not the actual length of it, but that's the length here using p-pad. It would be 2 squared plus 3 squared, which is 13, so that's root 13. Do you really care? These are both root 13 in length. If I know all 3 sides have to be the same, there's only one way to make it. So side, side, side is enough to prove that they're the same, right? If I were to take that root 13 and move it around, change the angle a bit, it wouldn't be a triangle, right? It kind of locks it in place, as we discovered with this. There's only one way to make a triangle with those 3 lengths. So, angle side doesn't work, because that's not enough to prove the triangles are the same. I can give you a triangle that has the same angle and the same side, but are different triangles. So, test the rest of these, like angle, angle, side, side, to see if that's enough to prove the triangles are the same. I'll walk around and help you guys. I know this is different and weird and out of the box. So the best thing to do is give it a shot and try it, and when you have questions, raise your hand. I'll walk around and help, okay? How's it going?
I'm just doing that one.
Okay,
I just
good.
finished.
Yeah, that's fine. Yeah. Do you understand the concept here, what's going on?
Yeah.
Okay, good. Awesome. Any luck? Understand what I was doing? Okay. So we're going to check all of these. Let me throw my chart up on here.
Looks better. See, like, my shoulder better.
So we know that if all of the angles and sides are the same, then the triangles are the same, right? What we want to know, is there a shortcut? Do I need to check everything every time? No. Turns out I can just check all 3 sides, and that's enough, right? What about if I just check 2 of the angles and 1 side? Is that enough to prove the triangle's the same? Try that. So make yourself 2 angles that are the same using your protractor, and have them have 1 side the same. I like to draw my sides
Only
first.
6 hours and 15 minutes to get it.
So give yourself a side of 4, good, and then make 2 angles that are the same. See if that's enough. Give them thing. Which paper? Yeah, Daniel. Work together so you don't have to check all of them yourself.
I need help.
I'm here.
Me too, because I don't know where to start.
Okay, so that's a really big one. All right, so
Wait, that's the one that we did together. That's the one we did together. 50-degree one That's just how you showed us how to draw it.
Okay.
Cool.
So, side of 4, right?
Yes. Here, mine's right here. The 4 one. Stop flexing.
Good. Okay.
No, I'm just trying to help.
So we know this is 50 degrees. Now, which one do we want to check? You want to check the 2 angles one side, or?
Yeah.
So that's fine.
Yeah.
Okay.
Yeah.
Okay, so we know that we need to have 2 angles the same and one side the same. So let's make another triangle with one of the sides the same and the angle the same. Draw another 50 degree here. Check some graph paper so it's easier to draw sides and the same. There you go. You don't have a lot of room, so let's make some room for it. Here.
No.
I'll move this stuff.
It's not possible. I did it. I'm done.
You can check all of them, baby.
But the other ones aren't gonna work.
How do you know?
Because
Alright, cool. So that's 50. So that's 50 and that's 50. Now we need to check with another angle because we're checking angle, side, right? Okay, so we need to make another angle that's the same. What angle measure do you want?
50.
Another 50. Ooh, nice. Okay, so that's 50.
Wait, is that even on?
So this is 50. And this is going to be 50. Okay. So, knowing just this length and 2 angles, is that enough to prove the triangle's the same? Nope. Now, this is not a triangle, but if I shrunk this down, I could make it so it would be. You see if I shrink this, it would eventually connect, right? I'd have to shrink it. I'm allowed to do that because that side's not locked in. Same thing here. So it takes a little bit of visualization, right? But that's what's gonna get you done. Now, this is not enough to do that, just like that. But if we were to shrink this down a little bit, to where this is going to connect between here and here, let's find a 50 degree angle. Let's see. 50, 50, 50, 50. So 50's right there. That looks like, so we go through, am I eyeballing here? So that's 50, and it would connect. Okay, let's do that here as well. Oh, there it is. There. Oops, I missed. Are those triangles going to be the same, those two? They are, aren't they? So this will be enough. Right, so it looks like it wasn't, but if you actually adjust it so it does make a triangle, and again, we're talking about triangles here, this would be enough to prove it.
Yay, we're
Okay,
done.
not yet. Let me show everybody what we did. Okay. So for those of you confused, we just tried angle, side. So we set 2 angles that are the same, 50 and 50, 50 and 50, and one of the sides being the same. Now, Taylor at first was like, these aren't the same triangles, right? They don't even make triangles. So we had to adjust them to make a triangle. So we shrunk down those sides. That way they would connect with the 4. And when we shrunk them down to make that 50 degree angle connect with the side of 4, we created these 2 triangles. That triangle and that triangle. And it turns out if you measure them, they're exactly the same. So angle, side is enough to prove these 2 triangles will be the same. If you just know 2 of the angles and 1 of the sides, it is enough to prove that they're the same. There's only one way to make it. To show it with these guys, which I think is a little bit easier, let me zoom out. I'm going to set an angle. And another angle. So those are the 2 angles I know. The side lengths can be adjusted except for this guy. So I'm going to use this guy as but the angles have to be the same. two angles in this side length, there's only one way to make the triangle, and it's like this. Same thing with any other lengths that I might use. So I want you to go home, and your homework for tonight is to figure out which ones are the minimum that you can use to figure it out. We already figured out from today that this is enough, triple side. We also found out this is enough. Go home and check out ASS, see if that's enough.
What if we can't figure it out?
Do the best you can.
What if we
Where's
don't have
AS?
time? Yeah, what if we don't have time?
Well, how does my homework work?
Do Friday.
Thank you. What?
Where's SAS?
SAS?
Yeah.
It's this one, just in a different order.
Okay, I know.
Now, another question you're going to have, angle side side versus side angle side, right? It's the same letters, just different order. Does that matter? So if we have an angle and two sides in that order, is that different than having a side angle side? Check that out. Come in tomorrow with questions. First day is always weird with this stuff.
Yeah,
I'm slightly confused, but
Yeah.
like at the same time I'm not.
If you're not slightly confused, you're not really thinking about it.
Yeah.
It's
I'm
weird.
always confused.
Thinking of angles without thinking of sides is really hard to do.
Yeah. Sure, stop.
Goodbye.
Bye-bye.